Welcome, ladies and gentlemen. So what I like to do is show you how to compose as well as evaluate the composition of two functions. So I have, what we're going to do is compose f of g of x, g of f of x, and then we're going to evaluate the composition for 2 and for -2. Now, the main important thing when we're composing function, basically what we're doing is we're evaluating one function for using another function. And the best way to kind of explain is we can rewrite these a different way. And a lot of times I prefer to rewrite them. So this first example, I'm actually going to use them in the rewritten form. But you will see them both ways. So f of g of x can also be written as f of g of x, making it look like this. But I like it that way because what this shows us is what we've kind of done before. I am now going to plug in g of x in for f of x. And you might say, or in for x into the f of x function. And you're like, what does that mean again? So let's go back and look over at f of x. If we know f of x equals 3x, right? If I said, what is f of 2? Well, what we do then is we would plug in 2 in for the x, right? So you'd say that would be 3 times 2. And then you could say f of 2 is equal to 3 times 2, which is 6. So what you can see in this case is instead of saying f of 2, now I'm saying f of g of x. So wherever there's an x, instead of plugging in the 2, like I did here, I'm now going to plug in g of x. So really what this looks like is f of g of x is equal to 3 times g of x. You're like, oh, OK. Well, g of x isn't a number. G of x is a function. And we're actually given g of x. What does g of x equal? X plus 5. So then really, f of g of x is equal to 3 times x plus 5. Well, now I can obviously simplify that. So f of g of x is equal to 3x plus 15. And there you go. OK? So now, if we're going to go ahead and do the next one, basically what I'm going to do now is basically now I'm going to do the exact opposite. Now I'm going to plug in the f of x function into the g of x function. So again, this one looks like g of f of x. OK, it's the exact same thing. So now, basically, what I'm going to do is g of f of x is equal to, now I'm going to do f of x. I'm plugging that in for the x plus 5. Well, what does f of x equal? F of x equals 3x. So g of f of x equals 3x plus 5. And that's it. I can't simplify anything from that. So that's going to be the end. Now, here, what we're going to do is instead of rewriting our composition in terms of x, we're going to actually write it in terms of our value. So we're actually going to get the value. Well, what's nice about this is we've already composed f of g of x. We already know f of g of x is 3x plus 3x plus 15. So now I'm just going to plug that in for 2. Or it could also look like this. So we know that if we already know that f of g of now, basically it's going to be of 2. So we have 3 times 2 plus 15. OK? So basically what we're doing is instead of using x, we're composing it using evaluating with 2. Well, 3 times 2 is 6, plus 15 is going to be 21. And then over here, we're doing the exact same thing. So we'll have g of f of -2. And that's basically going to be 3 times -2 plus 5. Well, 3 times -2 is -6. -6 plus 5 is -1. So I don't want to, hopefully I didn't confuse you by rewriting it the other way. I think that rewriting it the other way just kind of makes more sense to me. So that's why I did it. But we don't have to rewrite it the other way. And when I do this one, I'm not going to rewrite it the other way. I'm just going to kind of go through the problem and show you, what to do. So in this problem, though, so if we're going to do f of g of x, if you can just remember f of g of x, take g of x and plug it in for f of x. So actually, oops, that wasn't supposed to happen. What I am going to do in this case is I am actually going to color code these. I think that might make this a little bit easier. Let's do f of x equals 3 minus x. Let's use green. OK, then we can tell which one we're going to be plugging into the other one. So, so the first one we're going to do is f of g of x. Okay, so what that means is I'm going to plug the g of x in for x. So it's going to look like this. F of g of x is going to equal 3 minus, instead of x, it's going to be g of x. Well, what does g of x equal? 2x squared plus x plus 5. Okay, then now, obviously, to simplify this, you see that we're going to want to apply distributive property and distribute that negative sign. So therefore, my final answer is f of g of x equals 3 minus 2x squared minus x minus 5. I can combine the 3 minus 5, which will be a negative 2. So f of g of x equals negative 2x squared minus x minus 2. When I rewrite it kind of like in descending order form. OK, so now let's go into g of f of x. Now I'm going to plug in f of x in for x into my g of x function. This one does not look like it's going to be a lot of fun. So I'm going to use a little bit of extra space here. G of f of x equals 2 times, well, not x squared, but it's going to be f of x. Well, what does f of x equal? 3 minus x. Or, yeah, squared plus 3 minus x plus 5. So now, you see here, well, to simplify this, now what I have to do is I have to square 3 minus x, and then simplify that, and then multiply it by 2. So, 2 times, let's do 3 minus x. Let's do a little work over here. So 3 minus x squared is going to be 3 minus x times 3 minus x, right? Apply FOIL here. So 3 times 3 is 9. 3 times negative x is going to be negative 3x. 3 times negative x is going to be 3 minus or negative x. And negative x times negative x is going to be a positive x squared. So therefore, I have x squared minus 6x plus 9. OK, so not that bad. So therefore, I have 2x squared minus 6x plus 9 plus, I really don't need parentheses here, 3 minus x plus 5. But the reason why I said I didn't need parentheses here, I need to keep the parentheses because I need to apply distributive property here. So therefore, I have 2x squared minus 12x plus 18 plus 3 minus x plus 5. And I decided not to combine those, so therefore I can see, well, what are all the numbers I can combine? Well, I can obviously combine my x's. And then you can see here I have all these numbers I can combine. So my final answer is g of f of x is going to equal 2x squared minus 13x plus 21 plus 26. Whew. Didn't look like a lot of fun, but we did it, right? It wasn't that bad. It's possible. It just took a little bit extra work. So now let's go ahead and evaluate. So the nice thing about at least evaluating is we don't have to do all that math again. All we simply need to do is plug in those numbers in for the functions now, right? So in this one, so f of g of 2, all we're simply going to do now is plug in 2 in for our x. So that equals negative 2 times 2 squared minus 2 minus 2. Just notice whenever I plugged in a value in for x, I used parentheses. And that's very, very important to be using those parentheses, because that's where a lot of students are going to make their mistakes. So therefore, that becomes 2 squared, which is 4. So I have negative 2 times 4 minus 2 minus 2. Negative 2 times 4 is negative 8 minus 2 minus 2. And I did these out just because this can get kind of confusing. So you have negative 8 minus 2, which is negative 10, minus 2 is negative 12. So we have f of g of 2. OK. Now let's do the not so fun one. Oh, what am I doing? That's from another problem, isn't it? Oh, no. OK. Well. So now let's do g of f of negative 2. So now I'm going to take this function, and I'm going to plug in negative 2. So I'm going to have 2 times negative 2 squared minus 13 times negative 2 plus 26. OK, so again, we have negative 2 squared, which is going to be a positive 4. Negative 13 times negative 2 is going to be a positive 26 plus 26. Negative 2 times 4 is going to be an 8 plus 26 plus 26. So 26 plus 26 is going to be 52. Plus 2 is going to be 60. So g of f of negative 2 equals 60. So there you go, ladies and gentlemen. That is, there you go. So there you go, ladies and gentlemen. That is how you compose a linear as well as a quadratic function and evaluate for their composition. Thanks.